key questions. Sorry, about the average rate and instantaneous rate. And I told you what is the difference between the average rate and the instantaneous rate, and how to write both the rates. Clear? Now we have some very important in-text problems. Please open, all of you, NCERT book. Page number is here, and the first question is 4.1. 4.1. What does the 4.1 tells you? I am reading the question for you. For the reaction R turning to P, the concentration of reactant changes from 0.03 m to 0.02 m in 25 minutes. Calculate the average rate of reaction using units of time, both in minutes and seconds. So here, how do you solve this problem? We see here, the reaction is given to you, R turned into P. So, the average rate is equal to minus delta R over delta T. I can write minus R2 minus R1 upon T2 minus T1. Average rate, I can write R average is equal to this. Put all the values here. I get this here. Now, converting minutes into seconds, I write here rate is equal to this much upon 25 minutes become 25 into 60 seconds, and your answer is 6.66 into 10 to the power 6 ms inverse. This is the first in-text problem based on average rate of reaction. Remember, numericals would be asked on both the rate, either the average rate or the instantaneous rate. Let us see problem 4.2. What is 4.2? Please see your NCERT books. I read the problem for you. In a reaction, twice A giving you products, the concentration of A decreases from 0.5 mole per liter to 0.4 mole per liter in 10 minutes. Calculate the rate during the interval. Please see here. The reaction is twice A giving you products. Average rate is equal to minus half delta A over delta T. That is equal to minus half A2 minus A1 upon T2 minus T1. Now put all the values. These are the values, and putting these values here, your answer is 5 into 10 to the power minus 3 n minute inverse. Both these problems are based on average rate of reactions. Now I come to the new topic today, that is the dependence of rate on concentration. What do you mean by dependence of rate on concentration? When a chemical reaction proceeds, the reactants get converted into the products. As a result, the concentration of the reactant decreases while that of product increases. This behavior is shown graphically. I can show this behavior graphically. See here, the concentration of the reactant is decreasing while that of product is increasing. Now, in this diagram, we can very clearly see the behavior of both the reactants and products, how they are behaving. It is very important for you to know such things. It is clear from the figure. I told you that the concentration of the reactant is maximum at the start. The reactant is maximum at the start. Please see this value, and therefore the rate of change of concentration is also maximum as the reaction proceeds. The concentration of reactant decreases, and it brings about the corresponding decrease in the rate of reaction. This means that rate of reaction is directly proportional to the concentration of reactants. Always remember, the rate of reaction is directly proportional to the concentration of reactants. Well, now coming to study of law of mass action. What is law of mass action? According to this law, at a given temperature, the rate of a chemical reaction is directly proportional to the product of molar concentration of the reactants. Consider a simple reaction of the type A plus B giving you twice of AB. Now we apply the law of mass action. The Consider this as equation number 1. Here, A and B, this A and B are the molar concentration of the reactants. What is K? K is called constant of proportionality or rate constant or specific rate constant. If concentration of each of the reactant, now if the concentration of each of the reactant, that is A is equal to B is unity, that is both are equal to 1, then equation 1 becomes. Put this value here, I will see that rate becomes equal to K. What do you mean by this? Thus, the rate constant of a reaction at a given time is defined as the rate of the reaction when the molar concentration of each of the reactant is unity. That is why rate constant is also called a specific rate constant. Coming to some of the characteristics of K. What are the characteristic properties of this rate constant? Number 1, rate constant is a measure of a rate of reaction. Larger the value of K, faster is the reaction. Similarly, smaller value of K indicates slower reaction. Number 2, different reactions have different values of K. Number 3, at a fixed temperature, value of K is constant. However, it changes with temperature. Point number 4, for a particular reaction, the value of rate constant is independent of the concentration. These are the characteristics of this rate constant K. Tomorrow, I will continue with the next video. Thank you very much.